Well, hello. Hey, let's look at Unit 4 for review on particle motion. And let me see if I can get the screen to go. Particle motion is a topic that's well covered on the AP exam and one that you'll want to be very secure in your knowledge about. So let's just walk through some of the basics with particle motion. One is the position function. Often position function is referred to as S of t. Occasionally you'll see it as x of t. But basically this tells you the position of the particle, where it's located, whether it's to the right of the origin, to the left of the origin. If it had a negative position, it would be to the left of the origin. Velocity, v of t, is a result of the first derivative of the position function. And its units usually are distance per time unit, like miles per hour, feet per second, things like that. Speed, speed is defined as the absolute value of velocity, always expressed as a positive, much like the speedometer on your car. Acceleration, a of t, is the first derivative off of velocity and the second derivative from the position function. Acceleration, we know that this is a unit measure of the change of velocity. So we get the distance per unit time per unit time. So I have velocity, distance per time, and then turn that velocity into a rate. How fast is that velocity changing? So I get time per unit time. Often you'll see this as feet per second squared, as an example. All right. Some statements, ways to justify. So if you were asked to say, is the particle moving up or towards the right? I would justify that by looking at the velocity function. And that velocity function velocity is positive. So if v of t is greater than 0, then I know my particle is moving to the right. I can say the particle is moving to the left on a time frame like from 3 to 5 seconds when v of t is less than 0. The particle is rest when v of t equals 0, and the particle is speeding up. Well, this gets a little tricky. When is the particle speeding up? When the velocity and the acceleration are working together. They have the same sign. They could both be negative, or they could both be positive, and that will cause the particle to speed up. And then you guessed it, it's slowing down when v of t and a of t have opposite signs. So that is what you can write down for your explanation as to why it slows down. V of t and a of t have opposite signs. Somewhere in your work, you'll have the evidence showing that you had one positive value and one negative value for either of those velocity or accelerations. Particle changes direction. The particle changes direction, well, it has to come to rest in order to change direction. So we talk about it needing two particular things here. One is the velocity does have to equal 0 at some point, and that's at the point at which it can change direction. And then we have to look for our velocity to have the change in signs going from a positive to a negative, perhaps. All right, if you need to pause, go ahead and pause so you can write all the rest of that down. Then we go into example number 1 as a good little review here. Example 1, a particle moves along the line so that its position at any time greater than or equal to 0 is given by the function s of t. Looks like it's cubic to me. Where s of t is measured in meters and t is measured in seconds. So we're given the position function. Find all the times t at which the acceleration of the particle is 0. So as I read that, there was a couple key pieces. I want to find acceleration, and I want to find when that acceleration is 0. So now I got to think back in my mind, how do I get to acceleration? Well, acceleration is equal to s double prime. So I'm going to go ahead, and there's nothing wrong with writing that down, right? It conveys information to the person reading your answers. So let's get a first derivative to get things rolling. So s prime would be 3t squared minus 12t plus 8. One more derivative so we can get to our acceleration. And that would look like 6t minus 12. I want to find when the particle has an acceleration of 0. So I want to know when this equals 0. And, this is easy enough. Either you could factor it, or I'm just going to quickly solve it here, divide by 6, and I get that the time is 2. So I'm just hitting time equals 2. If we had to talk about units, it'd be 2 seconds, because time was measured in seconds. Part B. At time equals 1, is the particle speeding up or slowing down, and justify your answer. So I remember from the prior page, when we talked about speeding up or slowing down, there were two things that I need to talk about. Oops, I'm having some issues here. There we go. V of t and A of t. I've got to compare their signs. So let's go find what A of t and V of t is at 1. So V of t, I'm going to establish that I know how to get V of t by showing it's S prime. And we had it from before, 3t squared minus 12t plus 8. Evaluating V of 1 would be 3 minus 12 plus 8. Looks like we get a positive 1 on that. Oh, I'm sorry, negative 1. Let's get that. It looks a little nicer. Yeah, minus 12 and a positive 11 would make a negative 1. All right, A of t. A of t we have as S double prime, and we have that written up above, 6t minus 12. Evaluate that at 1, and I would have 6 minus 12 giving me negative 6. And looking at these signs, do a comparison. I notice that they have the same signs. So my particle is going to be speeding up. The particle, with justifying, we should write a nice explanation on this. The particle at time 1 is speeding up because V of 1 and A of 1 have the same sign. If you wanted to state they're both negative, that's fine. They have the same sign. But that is enough justification right there. All right, moving on to part C. I think there's a part C. Nope, I'm sorry, there's just 2 parts. Okay, next problem then. On to example 2. Example 2, for 0 to 14. For a time interval, 0 to 14, the velocity of a particle is given by V of t, measured in meters per second, where t is measured in seconds. The graph of V of t is shown below. For all times t at which the particle changes direction, find all times t where the particle changes direction, and justify your answer. So I know that for a particle to change direction, I need my V of t to equal 0, and I need the velocity to change signs at that particular spot. So that's kind of what I'm looking for when I go over to my graph. Now, the graph that we're given is V of t, isn't it? So I can read it directly. It would be equal to 0 when it strikes the x-axis. So I've got 3 potential places here where V of t is equal to 0. And here it was positive changing to negative. This was negative changing to negative. Well, not really changing, staying negative. And this was, negative switching to positive. So I think I have 2 prime locations that I would say, oops. Oh, come on, pen, back pen. I'm having difficulty here. Okay, got the pen working. So we have two prime spots that we are interested in, here and here, because we have the sign changes. Not only is velocity equal to 0, but we have sign changes. So find all the times at which the particle changes direction at t equals, trying to read these, 1, 2, 3, 4, looks like 5, and t equals 10, 11, 12, maybe 13 out there, at time equals 5 and time equals 13 seconds, because v of 5 equals 0 and v of 13 equals 0, and velocity changes sign at each at each at each moment. And that should be a pretty good explanation. All right, part B. What is the acceleration of the particle? Let's see if I can see all this. I'm just going to erase what I had there. Okay, what is the acceleration of the particle at 5.5 and indicate with the proper units? So I know acceleration is a result of the derivative of velocity. So since I don't have a function to take a derivative of, I have to use the graph that I'm given, which is a velocity. And in order to talk about the rate of change of velocity, I'm going to read the slope of the curve. So a of 5.5 is equal to, let's go find 5.5. 5.5 right in that mark. Now what I need to do is be able to calculate what the slope is there. So I'm going to go down 3 and right 1. So I'm saying that the slope is -3. And velocity would have been, somewhere they told us, velocity was measured in meters per second. And this is a rate of change of velocity, so meters per second per second. If you'd rather express it as -3 meters per second squared, that's just fine. Okay. AP exam tips for the day. Know how to move yourself between position, velocity, and acceleration, given any of those starting equations. Earn easy points by knowing how to justify your answers. We talked about that in the beginning in that little table. When a particle is moving left, it's because its velocity is negative. Particle motion questions. There's a lot of different styles of particle motion. We can talk about vertical movement, horizontal movement. They show up often on the AP exam. So that is where we're at. For homework, you've got the free response question. And also there is a multiple choice set, 10 questions on that you can upload your answers. So have a good day. Thank you.